In this video, we cover the Start Jobs feature. Start Jobs is a property set in the job stream. Its purpose is to improve monitoring by setting a hard start on the job stream run. It contains an explicit list of jobs that can initiate the run, thereby improving monitoring for that job stream. Without a start job, the default starting point is the very first job, in other words, the target job's earliest predecessor. That predecessor may not represent the natural starting point of a process we want to monitor, especially when executing for a different period, say the previous day. We use start jobs to set the job or jobs that can initiate the run. Monitoring can only start when that job begins. Start jobs are not enabled by default, and so we have to change a setting in the configuration tool. We'll show how to do this. Our demo scenario involves a batch process scheduled to execute at a set time, but that is conditioned by a predecessor running the previous day. We'll set the first job in the batch process as the start job. We'll also use the example of a short sequence that executes in a loop, in which the first job is dependent on the successful completion of the last for the previous cycle. We'll use start jobs to ensure that the monitoring starts with the right job. The purpose of the Start Jobs tab is to improve monitoring and optimize the accuracy of certain data points, mainly start time and elapsed time. Adding a start job means setting an explicit starting point for the job stream, meaning earlier predecessors will not be able to trigger a run. This guarantees we're monitoring the right items and that our data is not tainted with executions that aren't relevant to the overall stream. This is particularly important for batch processes that are set to start at hard times, say an end-of-day consolidation that runs every day at 6 p.m. We're interested in monitoring that consolidation process. We're not particularly concerned with what happens before. If predecessors exist, start jobs will guarantee that monitoring processes are not initiated with a job stream run by one of those predecessors. We'll monitor the core process and nothing else. Let's provide an example. We've created a job stream with a target job set to the last job of a workflow A. It's scheduled to execute every day at 3:30 p.m. The workflow is configured with an upstream dependency on some other workflow C, also executing every day but much earlier, and so it's not part of the natural cycle of the underlying process. We don't want these predecessors to start the job stream run or monitoring to begin. Monitoring should focus on workflow A. We set workflow A as the job stream start job. You have to enable start jobs in the AAI configuration tool. The setting is found in the Parameters tab of the tool. It's called client.enable jobstream start jobs. You set it to true and then restart the interface to enable the tab. We'll use one of the most common scenarios to explain start jobs and implement it in the interface. We have a basic batch process with 4 jobs executing in sequence. This process is scheduled to execute at a set time, and the last job has 2 external predecessors that execute hours earlier for another scheduling period, say the previous day. When the job stream is first created, default configuration dictates that the job stream run begins with the earliest of the 2 predecessors. This is reflected in the start time of the job stream in the Monitoring tab. IT operations do not want them to trigger the run so that monitoring teams can focus on the main process, which is the workflow. We set the workflow itself as the start job. The job stream run start time is set to the start time of the workflow. This is the job stream in AAI. The main process is set to start at 1:36, but the predecessors will start much earlier, triggering the run at 1:15. Note that in the real world, the time difference could be much greater, say hours or even the previous day. The run begins with the earliest predecessor, and this is reflected in the Monitoring tab. We have 2 completed runs for the consolidation job stream. Allowing the earliest predecessor to set run start time distorts the data presented here. Various data points like start and elapsed time are not reflected accurately because our focus should be the start of the workflow. We set the first job in the main batch process as the start job. If you're familiar with trimming, this isn't the same function. Trimming actually removes data from collection, whereas start jobs is primarily a monitoring function. We don't want to trim those 2 predecessors because they could conceivably execute at the same time as the workflow based on their relative start times or run times. Trimming them would cause potential distortions in the overall runtime analysis since they are part of the operational logic of the underlying batch process. We do not want to remove them from the job stream, and so trimming is not appropriate in this case. This is about preventing them from triggering the job stream run. By using the context menu in the Analysis tab, the job is added to the list of jobs in the Start Jobs tab of the job stream. We can add more, which might be useful in the case of more complex processes. Multiple jobs can start the job stream run. It doesn't have to be limited to one. The Finder offers two options, by job name and by job scheduled with start times. This makes sense. The purpose of the Start Jobs function is to hard set run and monitoring start times, and so naturally start jobs with hard set times are natural candidates. We cancel out and save the job stream with the current start job. Let's compare the new data with the data sets we saw earlier. We can see how the data changes. The two instances of the job stream started at 10 a.m. and 1:36 p.m. respectively, while they were previously set to 9:30 and 1:15. The runtimes have also evolved. The elapsed times and monitoring time spans have been pared down to produce more focused data points. Overall, we get a much more accurate picture of the job stream. There are other situations where start jobs can play an important role. Some schedulers allow you to build looping batch processes where the last job leads back into the first through a series of upstream dependencies. In this case, we can't predict which job will start a job stream run. To make this decision deterministic, you can use start jobs to set an anchor point for the start of the process, forcing monitoring to start from this point and move forward from there. The example involves a looping target job. There are two identical job streams. One has a defined start job setting, the other does not. Let's look at the first. The target job has a number of predecessors. We display the job details for looping box 1. Looping box 1 has a condition string on looping target job, which means that it executes when looping target job completes. We effectively have a loop, but because we've set looping box 1 as the start job setting, AAI knows exactly when to initiate monitoring. We can verify this by displaying other runs. We can see the contrast when we display the same job stream without the start job setting. In this situation, AAI is not in a position to determine when the job stream actually starts. From one run to the next, the job stream starting job varies. Now let's compare this with the job stream that has the start job setting.